Hello everyone. So in the previous video we saw what is LAN, what is WAN and what is MAN. So in this video we will see the network topologies. So there can be many different ways, maybe physical and logical, in which you can arrange the devices in a network, and according to this arrangement and according to this placement of the different devices, the data transfer or way in which data get transferred from one device to another device will change. So network topology is all about how devices are interconnected and how network resources are shared. So let's see some of the most common topologies or most common way to connect the devices in a network. So in front of us, the first topology is star topology. So in star topology, all the devices are connected to a central hub or switch. So here we came across the word hub. So let me explain to you. Hub is a device. Hub is a device which we use to connect the different many systems with each other. Okay, so what will happen? For an example, if this system sends some data to this hub will simply send this data to all the other systems which is connected to it. It don't care whether that data is meant for other systems or not. So that is hub. Hub is like a transferer. If one system sends some data to hub will simply take that data and send it to everyone. That's why we also call hub is a dumb device. It don't have much intelligence. On the other hand, switches also do the similar functionality, but but it transfer the data to the particular system for which the data is meant to transfer. Okay, so I won't dive deep into hub and switches. This all comes under the computer network components or hardware. So you can read about this. So the central hub acts as a repeater and the mass and manages the data traffic. If one device fails, it does not affect the rest of the network. So this point is important. The in star topology, the good thing is, for an example, if one device is down or stop working, so it doesn't matter, other device can still communicate with each other. But on the other hand, if central hub got disturbed and something happens with the hub, at that case, the entire network will go down. So this do have one single point of failure. Now let's see the second topology, that is bus topology. So in bus topology, everything is connected in the bus fashion. For an example, this system is connected to this system. This system is now connected to this system. This system is connected to this and this to this. So bus topology, all devices are connected to this single central cable or the bus. Okay, to this bus. The data travels along the cable and each devices on the network check for data with its address. It's simple, but can be prone to disturbance if main cable is damaged. Another way is ring topology. So in ring topology, devices are connected in closed loop. The data circulated in one direction, passing through each device until it reaches the destination. It is reliable, but failure in one device can disturb the entire network. Let's understand. So, for an example, if this system want to send the data to this system and data flow direction is, let me mark them. So let's say this is source and this is destination. So in star topology, the data flow direction is constant, though it is not strictly the case, but generally it is the case. Every time for sending each and every package, we don't change the flow settings, okay? But it is not a very strict that it must be same in every operation. So what will happen? A package will come from here and it meant for this system. So package will have some address, and it is true for all the other topologies also will have some address on the header. So how it will work? So it will send to this, and then this system will see, okay, is this package is for me? This is a my address. This system will say no, it is not a my address. So it will forward that package to this system. Again, it will see, okay, this package is for me. Answer is no. Then again, the package is forwarded to the next one. And finally, it will reach to this system or this computer. Here it will see the header and find out the address, and it will say, okay, it is for me, and it will accept it. So same concept will go to all the others. This also, for an example, if this system want to send the data to this system, so what it will do? It will send the data in this line, okay, in the central bus, and every system will see, okay, is this data is for me? No. This data is for me? No. Finally, this system will see, is this data for me? Yes, and it will accept it. And another topology is mesh topology. So in this kind of network, each and every device is directly connected with another device. What does it mean? For an example, this is the device, then it is directly connected to the every device. Let's see. This device is connected to this one. This is marked. It is also connected with this one. It is also marked. This is also connected to this one. Marked, marked, marked. So each device is connected to every other device in the network. And of course, here data flow will be much more direct. For an example, this is the source, and assume this is the destination. So it will send simply data in this line, and data will be reached. So you may ask, why don't we every time use mesh, right? It seems much more direct, and here data transfer must be fast because it is reaching it directly, and security is also more. Yeah, these points are perfectly true, but network configuration get really complex as size of the network increases. And if I want to add the another device to this network, then I need to connect that device to every other existing device in this network. So the things can get very complex if we are dealing with the large systems in mesh topology. Another one is hierarchical or tree topology. So in tree topology, each node or each devices have its children devices. Like device 1 have device 2 and device 3 as a child device. And similarly, device 2 also have device 4 and 5 as a child device. So basically, tree topology is combines the characteristics of star and bus topology. The root node, the main hub or switch, with branches and sub branches. It is commonly seen in wide area networks. So what will happen? For an example, this device want to send the data. Let's say this is the source and this is the destination. So what will happen? This device will send the data to this device. Here it will see, okay, is it for me? No, I will transfer it. Now it is transferring it. So here it will come. Now this device also see whether it is for me. No, it is not for me. I will transfer it to my children's and data will get transferred. Finally, the destination device will see the package and say, okay, it is for me. Now let's see the hybrid topology. Hybrid topology is a combination of two or more of above topologies. This is used to take advantage of strengths of different topology and to meet specific network requirement. For an example, if we see these three are connected in the bus topology, but each of this network is on star topology. So it is combining the bus topology and star topology. This could have been different. This could be like ring topology. If this device is connected to this device, there is another device here. It is on ring topology. And it is also possible that this device is connected with some bus also. So like this, there is a central bus and devices are connected here. And it is also possible that this device is in star topology. There is one central hub here and there are other devices. And it is possible this is on the tree topology. It have two children like this and this also have children, so and so on and so forth. So this kind of topology is known as hybrid. So here we are utilizing the multiple different type of topology in our network. So final one is point to point topology. So maybe you already understood it. It is point to point technology. Two devices are directly connected. It is often used in telecommunication and wide area network connections. Finally is wireless mesh topology. So in wireless mesh topology, devices are connected through wireless link. Every devices can relay data for the network. It is commonly used in wireless network and Internet of Things. Each of these network topologies has its own advantages and disadvantages. The choice of which one to use depends on factors like size of the network, cost, reliability, requirement, and the specific need of the network's user. So I hope you understood how topologies work and what is different types of network topologies. So that's it for this video. See you in the next video. Till then, bye.